Hey guys, this video is about converting from mole to mole. At this point, you really need to understand the mole ratio, which is your BMW over AMG formula that we recently learned. Okay, so make sure you brush up on that and you understand how to extract the variables out of the balanced equation, and at this point understand what is your given and what is your wanted. And you need to know that in order to be successful. All right. All right, guys, so let's get started. Okay, how to solve a mole to mole problem. Okay, the first thing you're going to do is write and balance your equation. Determine which sample is your given. You're going to use the big G, and wanted with the W. Determine your mole ratio. Okay, remember B is the coefficient in your balanced equation for your wanted. A is the coefficient in the balanced equation for your given. Okay, so general formula right here. This is in a lot of textbooks. This is the steps that we're going to be going. Amount of given substance in mole, and we want to convert an amount of unknown substance in mole, or wanted in mole. So this right here is where your mole ratio will go. So you're going to multiply your given by your mole ratio to calculate your number of wanted or your unknown. Okay, so let's look at this problem right here. Hydrogen plus iodine yields hydrogen iodide. Okay, there's your equation. It's not written out, but there's going to be times you'll have a word equation or a complete equation. So let's see what we got here. If given 5 moles of H2, how many moles of HI are produced? Let's follow 3 steps. Step 1, write and balance the equation. So here's our skeleton equation. We're going to simply balance it. Okay. So we have a 1, 1, 2. Okay. Now the coefficients equal how many moles are present. So you have 1 mole of H2 plus 1 mole of I2 yields 2 moles of HI. Okay. From the given data, determine which sample is your given and which sample is your wanted. Use the question to figure this out. Okay, so from the problem, we see that the 5.00 mole H2 is our given, and our wanted is the number of HI, or hydrogen iodide. Okay. Now step 3 is to determine your mole ratio. Take a picture of this. Remember this. A goes with your G, B goes with your W. So here's your mole ratio we did the other day, BMW over AMG. Okay, so looking at this equation right here, here's our balanced equation. Let's find our G, our A, our W, and our B. Okay, 5 moles of H2 is our given. So our given is H2 because it's in the problem. 1 is the coefficient for the given, for the H2. So A is 1. Our wanted is our HI. So W is HI and 2 is B. Okay, just like this. Okay, here's our setup. Now we take those numbers and we fill in the mole ratio. Okay, 2 mole HI over 1 mole H2. It's a little cut off on the bottom. So again, 2 mole HI over 1 mole H2. Okay. Now we're going to apply the mole ratio. Okay. So you're going to set it up just like this. You're given in the problem 5 mole H2 times your mole ratio, 2 mole HI over 1 mole H2. Do the math. 5 times 2 is 10 divided by 1. Okay, remember the H2s will cancel out. Get 10.0 mole HI, 3 sig figs. Why? Because there's 3 sig figs in the problem. Okay, let's do some practice examples. Now remember, sometimes the equation is written for you, or sometimes it's not, that you have to write it out. Okay, so sometimes it's easy, sometimes it's hard. So let's take a look at these practice examples. Okay, let's look at nitrogen gas plus hydrogen gas yields ammonia. Okay, so N2 plus 3H2 yields 2NH3. Perfect, so the equation's written. So from this equation, how many moles of hydrogen are needed to completely react with 4 moles of nitrogen? Okay, so we know what we have to do. We have to first find the balanced equation, then we have to find the mole ratio for it. So let's find the mole ratio here. We have our given, which is 4 moles of nitrogen. Nitrogens are G, and in front of nitrogen is a 1, so our A is going to be 1. So it says how many moles of hydrogen are needed, so hydrogen is our wanted, so our W is going to be H2. And in front of the H2 is a 3, which our B is going to be a 3. Okay, just like that. N2, 1, H2, 3. Okay, then from the problem we take our number, okay, 4 mole N2, apply it to our BMW AMG formula, okay, then we multiply. 4 times 3 divided by 1 equals 12 moles H2. Okay, remember the N2's cancel out. So cancel out the N2's. I know this might be cut off down here, but it's 1 mole N2. Okay, and you have 12 moles. 2 sig figs, 2 sig figs. Okay, now the next problem, why don't you practice it? We're going to start it, but you figure out your G, your A, your W, B, and you solve the problem. Okay, so let's do it. So you have potassium chlorate yields potassium chloride plus oxygen gas. Now, don't get confused. Potassium chlorate is the ClO3. Potassium chloride has no oxygen in it. The oxygen is liberated. Okay, so your balanced equation is 2KClO3 yields decomposition reaction 2KCl plus 3O2. So your question is, how many moles of oxygen are produced by the decomposition of 2 moles of potassium chlorate? So now find your G, your A, your WB, create your mole ratio, apply it to your 2 moles of potassium chlorate, and solve. Pause the video. Okay, so you have your G, which is KClO3, A is 2, your W is O2, your B is 3. Okay, so you have your given here. Okay, 2 mole KClO3 times your BMW, which is your 3 mole O2, over your AMG, 2 mole KClO3. Your mole KClO3 cancels out. Then you're left with a multiplication problem. 2 times 3 is 6, divided by 2 is 3. So your final answer is 3 mole O2. Okay? So it's quite simple if you take the time and follow the steps to really find your G, your A, your W, and your B. And it's basic math at this point. And you have to watch your sig figs. Alright guys, that's where we're stopping.